Good evening, everyone. This is not a video lecture that I would normally do for you guys. Tonight, hopefully it's going to be a short video that's going to walk you through how to do the calculations from the flame test lab we did in class today. So the first thing I'm going to show you on the next slide is how to convert from nanometers to meters. Then on the following slide, I'll show you how to calculate the frequency, or the V, and then I'll show you how to calculate E of the photon. And remember, E is standing for energy. Before we can actually get into calculating frequency, or that energy of the photon, we need to go ahead and get our nanometers into meters. And you might be like, well, where did I get my meters, my nanometers? Well, hopefully when you did your lab, you recorded the colors of light that you saw coming off of the out of the flame. And so, for example, if you said that you saw a red flame, if you look on the back of your lab, you're going to see like it'll say red, and it'll say that that is approximately like 700 nanometers. So you would go ahead and for your calculation, go ahead and use 700 or whatever other color you thought it was, and then the corresponding wavelength of light. So then here I've already written out some of the conversion factors that you might see. This is the one that I generally prefer to use. It says that 1 meter is equal to 10 to the 9th nanometers. Remember, nanometers are a lot smaller than meters, so that's why this conversion is working. On some worksheets, or different people like to use this, they'll say that 1 nanometer is equal to 10 to the negative 9th nanometers. And so you'll just have to set up your conversion factor appropriately. So I'll show you how to do both of those. So first you want to go ahead and write your given in that first box there. And using this conversion factor up here, I'm going to say that 1 meter is equal to 10 to the 9th nanometers. And so remember, when we're setting up these little equations here, we're going to take 700 nanometers and we're going to divide it by 10 to the 9th. And once you do your calculation, you should come up with 7.00 times 10 to the negative 7th meters. Some people prefer to use this conversion factor over here. Like I said, either one is fine to use. So just notice now you're just again going to put your given here. Here's your conversion factor. We said that 10 to the negative 9th meters was equal to 1 nanometer, and you should again come up with the same value, 7.00 times 10 to the negative 7th meters. So it shouldn't matter which conversion factor you use. Hopefully you're seeing that they're equivalent to each other. So on the last slide, we were able to calculate the wavelength in meters. On this slide, we're going to go ahead and I'll show you how to calculate the frequency of your wavelength of light that was given off by your flame. So when we look at this equation here, we have a value, we have C. Remember that C stands for the speed of light. I sometimes like to say it's the speed of all electromagnetic radiation. The value on your lab for C that it gives you is 3.0 times 10 to the 8th meters per second. I know we might have seen in our textbook or maybe in a video that it's 2.99 something times 10 to the 8th meters per second. It just depends on how you round the number, but your lab is giving you this value, so this is the value that we want to use for these lab calculations. So since here's our equation, but we're trying to solve for frequency, I'm going to go ahead and rearrange my equation and plug in the values. So here I've plugged them in, and we have 3.0 times 10 to the 8th meters per second. So remember, those are the units for our speed of light. And then down here is our wavelength value that we calculated on the last slide, now in meters. So you go ahead and divide these two values, and you should be coming up with 4.3 times 10 to the 14th, 1 over S, or sometimes we'll call that hertz as well. Now on this slide, I want to go ahead and discuss how to calculate E. So your equation for calculating the energy of a photon is E equals H times V. Remember that H is standing for Planck's constant and V is standing for frequency. So on the last slide, we just calculated for frequency. So we're going to plug that value for our frequency in here, and then we're going to use the value of H that they're providing. So again, we might have seen a slightly longer version of H, or Planck's constant, on our worksheets or in our textbook, but since your lab is saying just use 6.6 times 10 to the negative 34th, that's what we're going to do. And just as a reminder, Planck's constant has units of joules times seconds. So here I've gone ahead and plugged in our values. Here's H, or Planck's constant. Here's our frequency from the last slide. Go ahead and multiply those two. So just when I multiply these two things together, I'm going to come out with a value of 2.8 times 10 to the negative 19th joules. Notice how our seconds and our seconds here on the bottom are canceling out, and that's leaving us in joules, and that's what we want it to be in. I hope that this video was helpful in solving your lab. I'll see you guys tomorrow. Good night.